All right, it is May 31st. It is almost June. College is out. Summer is in. Memorial Day just happened. The year is going really, really fast. You can see my new background, the Digital RoundTable, now powered by Digital 360 Summit, which is coming up September 26th to the 29th at Texas State. We have a great guest today. But before we get rolling, we're going to ask our own John Sibley Butler for some music.
And I've been thinking about her. Well, I left for a good job down in the city, working a man every night and day. But I never got a minute of sleep. I was worried about the way the things might have been. Big wheel keep on rolling, proud Mary keep on rolling, and we're rolling, 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 rolling down the river.
Woo!
Well, I left a good job in the city, working for the man every night and day. But I never lost a minute of sleeping, worried about the way things might have been. We'll keep on turning, yeah, proud Mary, keep on burning, and we'll roll it. She's going to glory.
Excellent, excellent. Thank you, Johnny. Johnny, how are you?
I am doing absolutely fine. I'm a bit busy these days, busy with lots of stuff, busy with a lot of projects, busy with trying to make America better. I was very busy with Memorial Day, me being a veteran stuff, and working on, you know, the changing workplace in the state of Texas, the mobility. There was a big mobility conference here for the Renaissance here this weekend on how Dallas, Austin, San Antonio, and your place, San Marcos, will come together to be a major regional hub again in the country, and also following world politics and looking at the political situation here. Our chief officer here was, for the first time in my lifetime and also in Llewellyn's lifetime, he was recommended for impeachment, which is something new for the state of Texas since probably maybe 70 or so, but certainly just two since the Republic, and then the Republic became a state. So that's been taking up a lot of time. But the most interesting thing to me was Llewellyn's column on AI and what it would mean for the industry, for the electric industry. You know, we're back to calling it electricity now, the electric industry, right? Now that everybody is concerned with it. And that's certainly that's a formidable kind of worry as they prepare AI to take over a lot of the things that needs to be done. And I'm glad we have our guest today with Nouel to talk about how they get the technology on the grid. And also, of course, the World War is still going on. And as I said last time, people have gone from when Putin stopped the war or when the war stopped, what happens if he pushes the red button? So there's a lot of things that's going on around there. But other than that, you look at the economy seems to be doing well, jobs are being created. And more importantly for us in the state of Texas, we've had storms and the lights remain on.
That's right, that's right. Llewellyn King, how are you, sir?
Well, and thank you, Johnny. I have indeed been doing a lot of work on artificial intelligence. On yesterday, I did a virtual program, and part of a series I do with the United States Energy Association on AI in the utility space. We had some wonderful speakers, including EPRI and NVIDIA, and everybody wanted to talk to the NVIDIA guy because they're just had such a huge run up in the stock market. They all agree that it's coming. To some extent, it's here. That if you want really sophisticated interrelationship between many small generators, and you want really efficient demand-side management, and you're really going to have virtual power plants, you're going to need AI to manage this. The concerns which were raised were all the same concerns that have been raised. What about employment? And in the questions that come over the transom, which are always to me the most interesting, I can't get to all of them because they're in the dozens, and we have hundreds of people watch these programs. But they were all concerned with things like what about loss of employment, but also something, loss of skill. If we get so used to sitting behind a self-propelled aeroplane, well, we know how to fly it. And that analogy was put on the ground. Well, we have operators in utilities, when something goes wrong, who can jump in and do some kind of hands-on management. A lot of concern about disinformation in the system, bias in the system. And John Savage from Brown raised the issue of backdoors, where errors can be introduced into a system and remain there and cannot be detected. It was very interesting, but what I didn't know is the extent to which the technology has already arrived. Now, it hasn't arrived universally. All 3,000 plus electric utilities have not yet used AI, but there are a lot of vendors out there offering AI services, and that's a challenge for the utilities as to how they qualify them, how they work out who is able to do this job and move them forward. So it's an incredibly interesting time.
Okay, great to hear it. Well, we have a great guest. I'm going to introduce him a little bit formally, but first let's just say hello. Carlos Nouel, how are you, sir?
How you doing, sir? Thanks for the invitation. Hard to follow John with that music, so I'll try to do my best.
Absolutely. Well, for those...
My wife, Linda, was singing along, and she would just as soon that I don't say anything and yield my time to Johnny to play the guitar. Well, she knows
that sounds like a great idea.
The concept of yielding time to Johnny is outside of my ability to absorb.
Yeah,
well, Llewellyn, through the years with the women, the guitar has always offered a competitive advantage.
Indubitably.
Let me introduce Carlos formally for those listening and watching.
Can you talk dirty too, Carlos?
Let me introduce Carlos formally, guys. Carlos is the Vice President of Transformation Programs at National Grid US. And he's going to be with us for the hour. He's been with National Grid quite a bit. He's had multiple roles there, including things that he does for the corporation, like being the executive sponsor for the Hispanic Employee Resource Group. He's been the VP of New Energy Solutions, Director of Partnerships in Smart Grid, Project Manager and Category Manager for Goods and Services and Energy Efficiency. And then prior to National Grid, he's actually worked with many other multinationals, including Pfizer, British American Tobacco, IBM, and AES Venezuela, which owns Electricidad de Caracas. Carlos holds an MBA from Holt International Business School, a BS in Industrial Engineering from Universidad Católica Andrés Bello, and a certificate of innovation in business and management from MIT Sloan School of Management. Welcome, Carlos.
Thanks, Andres. And you forgot to mention that we're fellow Venezuelan.
That's right. Yeah, born in the most beautiful country in the planet.
That's right.
For sure. Carlos, there's a lot going on with your company. And I suspect that you get to see what goes on in the UK as well. You have a large footprint in the US and a lot of responsibility, and then you have a UK mothership, if you will. Tell us a little bit about your role and then what's going on with National Grid and some of the things that we could dive into asking follow-up questions.
Sure. To me, I think the time that we're living in is so exciting. You know, I always tell people when they think about energy, they're like, "Oh, really? That's not that exciting. That's not really that cool." But you know, when you're talking about AI, you're talking about kind of connected cities, connected homes. It's just a different world. You know, we're thinking about changing transportation, that it's going to look different than the way it looks today, changing the way we're going to, you know, operate a grid that has been operated the same way for hundreds of years. You know, we're now going to operate, especially here in the Northeast, you know, how we heat our homes and businesses. And essentially a big part of my role has been at the forefront of that and, you know, thinking about kind of what tools and systems and solutions are we going to need and, you know, what products are we going to offer our customers to make sure that, you know, this future that we all talk about actually becomes a reality. And, you know, a lot of that, you know, it's driven by data, right? You know, how do we use that data that is being generated by newer devices, and how do we use it in the smartest possible way? What are the things that we need to watch for, and kind of what are the things we can start to take value from? And, you know, that's essentially where I sit at that kind of center of, you know, trying to think about what the future looks like, but also kind of trying to make the business and the utility more efficient. So it's a really interesting combination with a lot of challenges for sure. And, you know, one of the things that we're working on right now, which kind of is a good leading into some of the things we were talking about at the beginning. So, you know, National Grid is actually a late adopter to AMI in places like Texas, where, you know, pretty much everyone has an AMI meter. You know, we were early adopters of AMR, the old technology, which meant that, you know, we ultimately ended up becoming a late adopter of AMI. And, you know, one of the things that, you know, I really pushed hard on was, you know, we don't want to put the same meters that everyone else has put in, right? Those are fine and they're great, and for, you know, billing purposes they work perfectly fine, and, you know, some of the more traditional use cases, they're fine. But in my mind, you know, we really needed to push the edge on this, no pun intended. And part of it was, you know, how do we start to get kind of more data and more resolution on the data we're getting in real time? You know, I always, you know, I remember when we started talking about AMI, kind of in the Arafon days, it was like, oh, real time, you might get data like every hour, every 4 hours. And I'm like, it's not real time. Like, real time for me, it's like I do something and I see an immediate kind of piece of data. And that's one of the challenges we set for ourselves. We say, you know, customers should actually know what's happening in real time in their homes. And, you know, not only they should kind of have an idea of what's happening roughly, like what are the devices, but like a really good idea of like what devices are really coming on and off in their homes. And so we're really actually deploying a technology that is probably first of its kind, where we're really allowing for high level resolution on the meters, which means that, you know, customers can actually see load disaggregation to the level they haven't seen it before. And a lot of that is powered by kind of high level frequency sampling we're doing on the meter, and powered by a company we're partnering with between Lens and Gear and Sense, really to provide this experience to customers in which, you know, they can actually get to see what's happening in their homes in real time. And I think the other piece we really pushed on is, you know, when you think about all this data that is being produced, like you always have the question like, wow, I need to bring all this data back, do some computation, and then like send it back to either a customer or to a device on the grid. And in a lot of cases, that's not, you know, it's not possible, right? I mean, the amount of data sometimes it would be too much. So, you know, we said, you know, what about if we start processing at the edge, right? There's a lot of conversations around that, but, you know, this is probably the first time I feel we're actually making it work. So a lot of the things we're talking about are things that we actually run on the meter itself, and not necessarily have to bring them back into a central repository or doing something centrally. We can actually start to kind of send and produce a lot of the insights and insights in the meter itself, and then starting to provide that both to the grid operators, but also to the customers directly. So, you know, when you talk about AI, you know, for me, one of the things that I've become fascinated lately is, you know, with all this data, you need to imagine how powerful it's going to be to start using that data to think about operating your grid differently, right? And, you know, one of the examples I always give, you know, we've had demand response programs for a long time, right? And they're successful, they work well, they do what they're supposed to be doing. But in my mind, it's pretty much a sledgehammer approach to the problem, which is, you have a bunch of devices, you try to turn them all off during certain times or increase the temperature to get to an outcome. And the reality is, in the future, we're actually going to know exactly what's happening in the grid, right? It's less about like what total usage and what's happening in this feeder. Like, I actually will know that in this feeder, it's actually made of this. This is the makeup of my load at any given time. And I also know, because AI and kind of all the machine learning, I can actually know what's going to look, my load is going to look like based on weather and all the other factors in the future. So when I do demand response, as an example, I don't have to call every single device. I might want to call just the ones that I know are going to be making a difference in the grid, and not every single device. So those are kind of some of the early examples as you think about kind of what can we start using this data for. It starts to kind of bring a different perspective on kind of how do we operate the grid. And I'm just going to pick on the analogy on the plane, which I actually thought is a really fascinating analogy. So I'm a heavy user of planes, unfortunately or fortunately, depending on how you want to see it. But I'm actually a aviation aficionado. So I like to fly planes on simulators when I can. And to me, there's this concept where there's a perceived belief that automation essentially takes the skill away. Like, pilots still know how to fly a plane, but there's a lot of automation that's made it easier and safer and more comfortable for passengers with the automation that exists today in airplanes. But you still need to have the people that actually understand that, when that goes wrong, they still know how to fly the plane. And I think as an industry, I think we can learn a lot from that, right? You can land a plane pretty much, a Cat 3 plane, you can land it, pretty much by instruments. But you still have a pilot that if something happens, they can react. I think the grid is probably going to look something like that, where the grid is going to operate itself. You're still going to need skilled operators that are actually going to need to know kind of how to override or how to control it if things don't go as planned. So I just think it's an interesting feature for sure.
Yeah, absolutely. Gentlemen?
Yeah, well, Carlos, it's very interesting because you bring together things we've talked about on the program before. The technology, we have the data that's being produced, and then the customer satisfaction. And as always, how can the data provide better customer interface and make things cheaper for the customer? But we also know, as you're Vice President of Grid Transformation, we've discussed on this program all of the research that's been done on the grid that hadn't been utilized, that the technology transfer has not taken place. So my first question is, given all of the data points that you want to talk about and the use of data, and given the fact that you're dealing with one of the biggest machines in the world, and given the fact that the machine can range from 1920 to today, how do you see the utilization of technology that's sitting on the shelf already that's been done by the federal government that will allow the better utilization of the grid? And as we've said on this program before, if I'm still making billions of dollars on 1920 technology, why should I change?
Yeah, I think it's a great question. So let me start with that last piece of the question, right? I think all utilities are going to be facing some interesting challenges, right? I think customer needs are going to continue to increase, right? We used to live in a world where, if you lose power for a couple of hours, is probably somewhat acceptable. But, I'm working from home, and I can tell that probably most of you are working from home today, right? So if you lose power today, it's not just about the inconvenience of, well, I'm not sure it's going to get hot, or I'm not sure what I'm going to do for dinner tonight. It's actually, I won't be able to work. And, that means that utilities are going to have to kind of continue to invest heavily and smarter in resiliency and reliability to make sure that, they can continue to serve customers with those increased needs. But I think furthermore, as you think about electrification, both of heat and transport, you're also going to take a greater level of responsibility on the eyes of customers, right? Because you're not just, you're just not operating a grid that operates your home or business. You're now operating the network that ensures that you can move from point A to point B. And I would say the third component is, as you start to integrate those resources, whether it's solar, storage, wind, whatever it is, you're also going to have to make a grid that is a lot more flexible than it is today. So I think the reason why those three things are really important is because it's going to put a lot of cost and pressure on the financials of the utilities. And I think in a more traditional world, you would say, well, I'm just going to pass, the cost to customers, and like that's it. And the reality is that's not the way it's going to work in the future. It's going to become unaffordable for customers if we just keep adding and adding and adding, right? There's going to be investments that are going to be necessary. But I think utilities are going to be constantly challenged to look for ways to operate in a more efficient way. And I think that it's going to drive the need for saying, okay, well, if I have a use case to say I can avoid a truck roll and I can do switching without necessarily having to send people to the field, can I do it? Can I restore power with an outage using a flisser scheme and not necessarily having to, again, truck rolls and things that are really expensive? Those things are going to force, I think, the utilities and the industry to think about those tools and say, it's not an option anymore. It's not a small project. It's not a thing that I want to do because it feels cool. It's a thing that is going to be necessary for the survival of the business. So, so I would say, so that's kind of, I think, a big driver for why, even from a pure financial perspective, why this actually matters a lot.
Let me throw another variable in there of regulation. What I could do in my enterprise is that, it's not a regulated enterprise. I can really respond to the market in ways, but your enterprise is a regulated enterprise. So when we think about, just say changes in the nature of business models, in an enterprise that's regulated versus one that's not, then you're going to have a rapid change in the business model. So how do you see getting the regulators, quote unquote, in line with the new technologies that will allow better customer satisfaction and allow this machine to run better?
Yeah. I think regulators have an equal challenge to the one utilities have, right? I think regulators need to try to kind of ensure that the policy agenda set by their politicians and their constituents, it's being executed, which means that there's going to be greater investment. But they also need to recognize that there's a lot of people that are still having a hard time paying their bills, right? So they're going to live in those two worlds saying, okay, well, I want to do a lot, but I also cannot afford to pass all this cost to my consumers. And I think this is where there's going to have to be incentive mechanisms that really motivate the industry overall to drive some of the change and putting those incentives. So like in the states where we operate, there's, call it performance incentive mechanisms, earning adjustment mechanisms, different versions of it. And essentially what those look to do is essentially incentivize the utilities to say, move away from this cost of service model, where there's a place where that still makes sense. But there's other areas where, it actually is worth investing and motivating the utility and creating that opportunity to say, if you actually go and get creative and deliver on this aggressive policy goals, you're actually going to get a financial benefit from it. And I think aligning the customer interest, the environmental policy goals, and those incentives, I think that's where regulators are going to have to crack that code between those three things, because that's truly, to your point, that's what is going to make people to say, it's not about, I just want to do it. I want to do it. And there's also a financial motivation for us to actually do it.
Sure. I agree.
Well, thank you very much. Okay.
Let me ask you, I like, by the way, Carlos, your aviation analogy. I made it in different ways. One, that you're both in real time. You can't park the airplanes while you debate. You can't turn off the electricity while you retool. You both are at the behest of the weather, which you cannot control. And you have human control that has to be kept alert, which in the age of automation has been a long-standing problem. British Airways at one time, I don't know where it came out, spent a lot of time and money on their long-haul flights as to how to keep the pilots, once they had plugged in the autopilot, how to keep them interested. And the same problem, but much worse, is the problem of nuclear power operators, where nothing happens, except you have to be ready for something to happen, which is very hard to do when nothing happens. The weather factor is beginning to bear very heavily on utilities. I used to ask utility executives what kept them awake at night, and they would say almost always cybersecurity. But the last few I've spoken to, they've said weather, which is a substantial change. But nonetheless, the assumption that this will axiomatically be more expensive as we move into the high planes of technology may not be right, because the experience of technology is it's a cost reducer, not a cost increaser. So if it follows a traditional plan, there'll be expense followed by savings when it goes to scale. And it seems to me that AI running many of the functions of the utility, as you say, based on data, will be a cost saver and actually may help the investor and utilities like yours and the customers across the board. But I'm wondering about the unevenness which we may see in the and how we adopt these new technologies from a small electric rural cooperative to a substantial company like yours, or a very large utility owned like say TVA or public power entity. Some are more able to make the adjustments, but they're all part of the same grid. So you've got to look out for the little guy as well as the big guy. Otherwise, you'll get a deficiency and a liability on the grid.
Yeah, I think that's a really interesting question. And a few years ago, we actually deployed our ADMS solution, and if you think about it, power flow analysis and automated switching, that's that could be a scary thing. It goes back to some of the things we're talking about. And I remember working with the project team, and kind of one of the things we said is like, this needs to be an iterative process, right? Like, some of these changes are like changing fundamental things on the way we do work today and the way we've done work for a long time. And, in that example, for example, what we did is we took this approach of like, small incremental steps and a more agile approach, in which we were saying, early on, the tool is just going to inform you, right? It's not going to do anything for you, it's going to inform you. And the way we had it is, for example, on a power flow model, an operator would say, I have to go and do the switch because someone hit a pole, or we have to do maintenance, or we have a storm. And obviously the operator would still do all the same math that they do today. They go and kind of check with some of the other folks in the control room. But then they would also have the model from the computer, right? And it was like, okay, how does this model compare to what what would have done? And it's interesting. In a lot of cases, it was similar to what they would have done, but in a lot of cases, actually, I'd say operators were equally surprised and say, "Oh, actually, didn't think about this option." So I think to some degree, there's a lot of value in which technology can start to show how powerful it can be. But I think if you start to get it in incremental steps and walk people through this curve of change, I think people will be a lot more receptive. Whether you're working as more co-op or you work in a large utility, I think those incremental things take a bit of that fear and risk in the journey, and it kind of feels a bit more accessible to people, because you could say, well, okay, I understand now that the model is actually pretty accurate. So I'm actually now going to start to like enable the model to do more things for me. Still going to watch it, but now I'm going to let it do a bit more. And then you kind of keep iterating on it and adding more things, more data, more functionality. So I think this is going to be a journey. And in a lot of cases, I think once you do it once or twice, it probably will go faster. But I do think it's really important for people to take the time to recognize that, this is a change. And, I was in a panel last week at MIT, and, someone said, ultimately what people care, it's air conditioner and a cold beer. Like, it doesn't matter what happens with the grid. Like, the only thing they care is, air conditioner and a cold beer in the afternoon. And that's a reality, right? I mean, people still want to wake up in the morning, flip the switch, and make sure the thing works. So I think it is up on us to, as an industry, to say, let's just start to make some steps. And it makes it a bit less scary when you start to make some of those changes.
Yeah, let me ask you this. I've been
Sure.
actually writing some stuff too as you were talking. And I want to know about, just stick with the airline analogy. I like that too. And when there's a disaster, we learn a lot from that. When we had our problems in Texas, I want to ask two questions. Do you learn something from that, or do you say it was just a Katrina? And, does that mean that we're going to bury the wires, despite the fact that when they go out on the ground, they're much more difficult to fix? What are the lessons that you learn from other disasters, if you will, or things that do not go right?
Yeah.
And how will AI help us with that? So, and the other question is there such a time when the Titanic just sinks?
Yeah.
I'm a Southern Louisiana boy. Grew up with hurricanes all my life. Hurricane Betsy, when I was in school, hurricane, you name it, I can name them all. So how do you think about that? What were the lessons that you learned for your region when we had our problems in Texas, especially since you're accustomed to snow?
Yeah. Look, I think just starting on your analogy of the Titanic, unfortunately, I think we continue to be a service that, you know, our ship cannot sink. Like, we are so critical for society that we need to make sure that our sink is still afloat. But that doesn't mean that we cannot be more efficient, and it doesn't mean that we need to bury every wire that is available in the world. No, that's not necessarily the solution. But, you know, I'll give you one example in which data can be really powerful, and I'll just pick it on the weather side. You know, we a few years ago we did this model in which we started to look at localized weather information and how that weather information can actually predict the type of damage you would have, right? And a lot of that was because we realized that if you actually had a weather sensor close to your asset, whether it's a substation or a transmission tower, your ability to predict the type of damage you are going to have based on wind, based on humidity, based on temperature, increased significantly, which would then allow us to then reposition our crews in a more effective way, right? So rather than saying I'm going to put, you know, in large states like Texas or even in New York, I'm just going to put all my crews here and there, you essentially start to look at data and say, actually, I can predict that most likely the damage we're going to experience is going to be this time, and it's going to be roughly in these places, which means that you can prepare better before the event even happens. And you can have, you know, the right materials, the right crews, the right people, kind of somewhat in the areas where you're going to have the outage, right? Is it going to be perfect? No, but, you know, like every model, it's probably going to get better as time goes by. So I think that's probably one of the things where I think data can help us on the reliability side. I also think, you know, we need a world that it's a lot more distributed and a lot smarter in terms of how do we do things, right? And definitely a lot more resilient. In the Northeast, we've been getting hit with bigger and stronger weather events every year. You know, and I'll just use kind of a couple of examples. You know, the way we've designed our AMI network, you know, we essentially are having almost like double and triple redundancy in a lot of places to ensure that we can still, you know, serve customers as much as we can. But it also, I think it's going to become probably even more important as we think about distributed resources and how those distributed resources can actually help us to restore the system quicker during certain times, right? I think that it's probably going to be an evolution because we need to learn a lot more about, you know, how do we isolate certain parts. But I think we're starting to see pieces with, you know, smarter schemes on Flisser, islanding capabilities of some devices that people that have batteries, can they start to backfeed with electric vehicles? So I think there's going to be a lot of things where, I mean, those lessons learned become like, okay, if this happens again, how do we go about it in a better way? I think there's a lot that it's been done, but I think there's definitely a lot that as more distributed resources become available, I think part of what the challenge we're going to have is how do we use them to increase resilience and reliability.
Well, let me just ask one question before we go. Do you ever think of a time, given the projections of the weather, that your business would be involved in a generation bit and generators? That is, every time you hook up a house, you automatically get a generator.
Mm-hmm.
And I think that if you look at another business models, I'm not saying that we should, and it would probably wipe out companies that do that now, and you know those companies. But do you think about not just saying the weather's going to get worse? You know, in Louisiana, everybody has a generator. But will there ever come a time when every one of your customers can go to you and say, I need a generator. Or in the future, as you service new places, generators become automatic. And not just the new battery stuff.
Yeah.
Not that's going back on the grid. I'm talking about the kind that run up on natural gas. And I won't call the name of the companies, but you know what I mean.
Yeah. This is short answer is I don't know. So I can tell you where I hope the world goes to. I hope that storage technology becomes so cost effective that you actually don't need the generator. I think there's two confluent things that are going to happen. I think the first one is hopefully storage continues to become more cost effective and it becomes more accessible for people, where the density is greater, when the cost is lower. And I don't think we're terribly far from it. I think the second part of it is I think homes are going to become smarter and more efficient. And I get it, that is going to be, especially in places like the Northeast where, we have a really old housing stock. But I think, newer codes, newer housing, it's going to be more efficient. And I think my hope is that in the future, that's the way we kind of think about it, right? Where, homes are an equal resources as a distribution demand, or also as a load or as a generation source that can bring power back, whether it's during emergencies or during blue skies. And I think that's why, for me, having the ability to run models on your network on a pretty much instantaneous basis, that's the thing that is going to allow this reality to happen, right? Because then we're going to be able to make better decisions and say, actually, we have a big, solar and storage facility in this neighborhood. Let's just isolate this whole neighborhood and feed it from this battery and storage. That's what I think. But that requires a lot of modeling. It requires a lot of flexibility on the customer side and say, you're going to still have power, but you might not be able to crank your AC or heat as much, right? But knowing what's happening in real time and that having what's the makeup of that load, I think is going to be really important for us.
Yeah.
So, if I had to bet, I would probably bet on that over having some of those generators that you're referencing. We might still have those, right?
Hold on, Llewellyn, give me a moment. Let me ask a few quick questions for Carlos. So
Sure.
Carlos, tell us quick rapid fire. What are
Sure.
you all doing with electric vehicles? What's going on with EVs?
Yeah, big push on EVs for us. Probably one of the largest EV programs in the state, both for residential customers, commercial, and public transport. For us, a lot of it has been around deploying charging stations, also enabling load flexibility for those EVs through time of use rates or incentive programs that encourage people to charge at off hours. A lot of focus on low-income customers, right? We cannot leave them behind in this EV world. And then the third piece of it is how do we reinforce the grid where it makes sense to make sure that we're ready ahead of time for EV deployment.
Yeah. Well, tell us real quick about the telecom infrastructure that you have and where do you see that going as it relates to fiber, 5G, 6G, real-time controls. Where are you guys thinking about all that?
Yeah, I think telecoms is a growing facility and growing area. I think we are trying to leverage fiber where we can. We don't have fiber in every substation, but we are trying to leverage fiber where we're close to substations, and that's going to be kind of one of the things we try to do. I was actually in Syracuse last week, and just to show how important telecom has become in our business. We have what we call this UTOC, which is the Universal Telecommunications Operating Control Room. And, it actually shows the same way we would look at the electric grid today. That's how we're seeing our telecommunications world, right? They're equally important because as many of our smart devices we have in the field, we're going to make sure that the telecom network that is behind them, it's going to be able to support and stay up and running. To support those great devices we're putting in. So I would say from a telecom perspective, pushing heavily on fiber. We still use 5G. So in a lot of places where, we're not close to a substation where we have fiber, we are leveraging 5G. It is a big investment, but we believe it's necessary. And we also have some private network in certain areas where it makes sense. But we are trying to push heavily on fiber where it makes sense and where we can afford it.
What's going on with smart cities, if any, and are your cities that you serve today looking at you as the big brother to help with the digital divide and how they improve automation?
Yeah, we've done a couple of pilot programs with cities around smart cities, around lighting controls, gunshot detection, traffic management, trash management. And I would say our current view is that it's still a bit early. Technology, it's still maturing, and we haven't seen the level of adoption that at some point we thought it was going to be. So I would say cautiously watching it, not necessarily a big push right now. I think it's going to happen. It's just the technology, it's still maturing.
Yeah. Last question, real quick. What are you doing with artificial intelligence, machine learning? Is it being used in multiple areas, call center, customer stuff, maybe the grid itself? What can you share?
Yeah, so we're using it on the customer side more for the disaggregation, like understanding kind of the appliance signatures, and so we can tell kind of customers, you turn on your dishwasher, you turn on your refrigerator. We're doing some early work on the grid side, but I'll say still early, a bit more mature on the customer side for now. We do things with speech analytics that use AI to understand, when someone calls, tone of the call and all those things. But again, still somewhat early in the journey.
Got it.
I think one of the things that it's really interesting for us is, like how the data gets shared and who gets access to what data. I think that's it's a growing level of discussion that we're having as an organization.
Carlos, yours is an international company. It's a British company primarily, and they've had a lot of problems in Britain. What have you learned from the British experience, particularly probably the over-dependence on wind in the North Sea?
Yeah, I think there's a lot of lessons learned. I think the first one is to your point about the over resiliency on one item, one resource, right? I think you need to have a mixed portfolio of resources that allow you to kind of eliminate some of the risk. I think one of the other big lessons learned is the amount of flexibility that is required, right? I mean, the markets and the flexibility, and how do you price out, people that are willing to say, I'm willing to curtail load, I'm willing to do this. It's not something you can wait until you have an event to have those programs in place. It's something we're doing not just on the electric side, but also on the gas side. So I think there's a lot of lessons around that. I think there's a lot of lessons around the customer engagement, right? I mean, customers are part of this journey, and they need to come along and they need to understand when there's scarcity, what does that really mean for them? And I would say the last thing, even in our own territory, right, with some of the price spikes we've had because of capacity issues on the gas side, how do we even change the way we procure energy, right? What are the different things we're doing, and using data from weather and behaviors and other things to kind of streamline and optimize how we do energy procurement to make sure that we can mitigate some of the price impacts to customers.
Yeah, I would think, Noah, that, one thing about data in and data out, as we said during my graduate school days, is that you've learned the theory that you need to test with all of the data. That's my first question. The second question is, Nouel and I are both AI units right now. John Butler is playing golf out on the golf course, and Nouel is taking in a show in New York. Now, I say that because when we started the program before, we had to make sure that we were not robots, that we were not AI. So if AI were to hit your market today, the space in which you play in, and as skills become obsolete, have you thought about how many people needs to be replaced, where they would be replaced? And you don't have to answer this question if you want to. But are you thinking that far ahead? Because I'm a robot, and Llewellyn is a robot, and actually, Andreas really programmed us all for today.
There you go. Look, so I don't have an answer on that. I think that's a really complex that's a really complex question. But I'll tell you my view of it. I think automation is always an interesting thing because it does feel like it's going to take a lot of jobs away. But I think a big part of what I think we all need to realize is that as an industry, we talk about transformation. Right, and we always talk about the systems. We always talk about all these things that need to happen, and the software and the hardware. The reality is, we also need to transform our workforce, right? I mean, we need to get people like, I would say, if you would have asked me, 5-10 years ago, do you have data scientists? No. Now we have a whole group that is dedicated to data scientists, right? So I think a big part of what we all need to recognize is that transformation is not just the business model. It's not just the technology. It's actually the people. And I think in some cases, yeah, there's going to be roles that exist today that are going to probably disappear to some degree. But there's going to be a bunch of new roles that are going to have to exist that don't exist today. And for us, I think that's one of the things that, I try to talk a lot to like school kids, whether we're in high school or whether we're in college. And I do think we need to get people excited about energy. We need to get people excited about careers and using AI for energy as much as it's been used in other things. Because the reality is, as an industry, we're going to need it. And if we don't have those folks in school thinking about it right now, we're just not going to have enough people to do the work we need to do. So, net, I'm not sure what the number would look like, but I would say, I do believe that there's going to be, some roles that will disappear, but there's going to be a lot of new ones that are going to be created.
Yeah, I agree with the opportunities. Anybody who has a degree in economics, they're a statistician. Anybody who has a degree in sociology, they're a statistician. Anybody who has a degree in economics, they're a statistician, right? So actually, statistics, which I think learning, it's just regression toward the mean and then making decisions. I think that people would have those skills, and I think if they're learning those skills. But this is what I find interesting. I think you need to theory, and I think statistics is something you just cannot pick up in the workplace. As a statistician myself, my work is because it's like a foreign language. It's easy to understand if you understand the normal curve, regression toward the mean, binomial distribution, and etc. But as a data scientist evolve, right? Everybody would be a data scientist. All football teams need data scientists. Yeah. They got all kind of analysts, right? Everybody need kind of analysts. So I think that what I find interesting about this is that you cannot pick up data science on the job for the most part. But I do think if you're an economics major or, sociology or psychology major, it's all been about data science. It's been about analyzing census data, predicting where people will be, what they'll do, and et cetera. So my big question has always been, with all of this data, and what I like about you is that I think you have the theory to test the information that the customer will need. Yeah. That is, you got to create the models, as you said. And when you create the models, you just can't do just do the correlation and run the analysis. But you got to create the model, and then from that model, say, this is the best model to reduce prices. This is the best model to predict, disaster. So I'm predicted that you will need more statisticians of what they call, sure, in your unit in the future of what they call data science. To me, it's just statistics. Right now, if we said statistics, it would scare people to death.
For sure. Right?
Yeah. So when we did our Master of Science in Finance, we didn't call it a Master of Science in Statistics. We called it a Master of Science in Finance, and nobody wanted to take statistics. Yeah. Right. Yeah.
And I can tell you, like, for me, I'm an engineer by trade, and I think for me, there's also, I think there's this concept of like, there's a lot of data, and I think that's fantastic, but like data by itself, like, it just doesn't do much. Like, I think one of the big things that we continue to try to push ourselves is, how do we provide real insights and really meaningful information to customers? And that's going to be an evolution, right? When we started this journey, we said, we want to provide real-time data, but like, what does that really look like? that was a big question. Now, we've tested with customers and saying, we'd like to see this. Will this be helpful? And, I always remind people, like, we're one of the few industries that we have to serve everyone. We don't get to choose who we serve. And because of that, we need to make sure that the insights we're providing are meaningful to those customers that we're giving it to, right? So those that, might be struggling to pay their bills, they all don't look the same, and you might need to give them different tools and different insights. And I think a big part of what as companies we have to do is like understand that and make sure that we continue to test and iterate on that, rather than saying, this is it, you got it, hopefully you like it, and like off we go. So I think not just the iteration and the insight, I think it's kind of how do you go about it, test it, learn it. And that's a whole principle about Agile. Like for us, that's how we do work. Like that's how we execute work every day. And while it might not be a perfect model to deliver things, I do believe it's a model that allows you to understand what outcomes and what things you're doing and whether you're hitting the mark or not. And I think a lot of that will be iteration with a lot of people thinking about it.
Yeah,
I'd like to ask you, Carlos, to what extent can you inventory your customer base without intruding into their privacy? For example, it would help a lot if you knew how many electric vehicles there were and how many were likely to buy them, how many were going to put in Johnny's charging stations and Johnny's individual generators, how many are likely or do have solar power on the roof but have not connected the solar power with the utility. For DER to really work, you need to have tremendous knowledge of the customer base, it would seem to me.
Yeah, look, I'm a firm believer that with great power, comes great responsibility. And my analogy is with a lot of data comes a lot of responsibility. And in our perspective, customers are in control of their data, right? Like we believe that customers have the choice and the right to say, I don't want to have my data being shared with National Grid or someone else. And well, that will make things perhaps a bit slower early on. I do think it's the right thing for us to do. Having said all of that, I think there's a lot of value with even anonymized data to make sure that you're understanding how the system operates in a much efficient way, right? Like for example, I don't need to know that Carlos or Andres have an electric vehicle, but I need to know that those houses on that feeder on that transformer actually have solar and storage, because then I will make better decisions if I know that, even if I don't know that it's Carlos and Andres. Right. So to me, I think there's a lot of value still in anonymized data to operate and do things better. I would say on the customer front, I do believe firmly that customers should give consent to start sharing some of that more personal data, because ultimately it's their data, we're their guardians. I do feel like more people are going to get comfortable sharing that data in the future, but I think this is going to be a journey.
Yeah, let's have one scenario, Carlos, and tell me how close we are for it to happen. What are your thoughts of this scenario? I know you've been working on it. You and I have talked about it. So I'm on the list for the F-150, my favorite vehicle, and my vision is that I'm going to come to the university, charge it up for free. Meaning the university will pay the bill, and then I'll drive home and I'll run my house from the vehicle. How far away from that coming together? What is the utility thinking about that reality possibility of 20 million vehicles in your service territory doing that? And what would that do to the business model, if anything? Any thoughts you can share?
Yeah. First, I don't think I'm hopeful that we're not that far. And I was actually having this conversation with someone the other day where they said, well, aren't you worried you're going to be completely dissociated from the process? And the reality is, I think if you're a customer and you only think about like, I'm going to cut the wire, where's the value then? Like my value of my resources when I'm connected to something else. Like that's saying like I'm in Airbnb and I'm not part of the network of Airbnb. Like wouldn't it be more valuable if your Airbnb would be in Airbnb, right?
Sure.
So to me, I think the value and the change for the utilities is going to be it's going to be less about like that's one-way power flow and like making sure that things work. And it's going to be more of an orchestrator, right? And that's a model that in the UK and in Europe, it's starting to get a lot of traction with this distribution network operator, distribution system operator, in which, it's the orchestration of, Andres got home and he has a battery and he's going to backfeed because we actually need it. But later on, we're going to tell Andres that it's actually better for him to charge because we have plenty of generation and no one is using it.
Right.
So I think for us, I think the change I see, it's more about the role we're going to play, which is more of that orchestrator and coordinator, rather than saying, oh, this is going to be the end of it. No, I actually think that the resources become a lot more valuable to the consumer as long as they're connected to a network where others can benefit from that resource.
Absolutely.
I mean, just briefly, I think you're exactly right, because what we don't know is how the consumer's workplace, what Michael would call distributed workplace, in his work, Michael Spears. I mean, because you have to prepare for that. And I can see AI, doing what we do by hand and automation, shifting the loads. So for example, if all professors stay at home and work, then the workload for the house is much greater. If all buildings are empty and they turn into condos, I mean, it's going to be a shifting of what people do, as you said earlier. So understanding the goals of people. So for example, some things a lifetime. So I know that if you played games of chance in your early days, and it was something that you do, I can go look in your closet now. You got a truckload of games of chance, but it was just something fly by. You have nothing, right? So I think it's good to look into the future and say, for example, they said that my generation would drink a lot of coffee. Well, they were wrong. We drank a lot of sodas. So if you invested in coffee rather than sodas, you were lost. So I think it's good for the utilities to come into the business world of predicting what people would do. I think right now we just want our lights to come on as a consumer. We have not thought about the complication of what you do. We just want you to show up on time and when your lights come on. So I think it's good that you're thinking about that, those kind of work distribution where people would be, who knows what the changing nature of what will fund the biggest machine in the world.
For sure. Look, I think that's why it's so important that utilities are connected to their local governments and economic development people, because, the reality is, this world can change again. And I think utilities are still that thing you said about people waking up in the morning, I don't think that's the thing that's not going to change is probably that. People are still going to wake up in the morning and they want to make sure their lights come out when they.
Absolutely. Without flickering, and I might add, without flickering.
Without flickering, exactly.
Yeah, absolutely. Well, Carlos, you've been very gracious. I want to remind everybody of our upcoming 360 Summit, and the fact that we are very excited about where it's going to happen and how things are taking place. And I wanted to, just remind everybody that the Digital 360 Summit will be September 26th to the 29th. It will be hosted at Texas State University, and it will be, a time to come and witness the transformation that we have been driving, that is really powerful. And I'm going to share my screen real quick to show you guys as a reminder. We are, have been building this living labs, and we are 30 days away from issuing an RFP for a 64 megawatt solar farm and 160 acres for the university. And we are going to build a $20 million facility, 15,000 square feet, AC bus, DC bus, voltage from 0 to 38.2 kV and from 0 amps to 5,000 amps. It'll be one of a kind. We will do EV charging and energy storage and green hydrogen and fuel cell and solar PV and power electronics, solid state transformer, R&D and things like that. And we'll have a new substation going for the digital 100% substation and control room and switchyard room. And we're looking forward to many companies joining. DOE, Oak Ridge, NREL, and Sandia are going to join the lab. So looking forward to that. We will have tours of what we're doing at Texas State. And these are some of the companies we had the blessing of having Carlos keynote the energy session last year. And hopefully we'll have him back again. And these are the focus of the labs. And we want to thank Texas State for sponsoring the Digital Roundtable. So Carlos, last thoughts, what keeps you up at night in the next 90 days or 160, 80 days? What are you working on in the, you feel free to promote anything you're working on or share anything you can.
Look, I think for me, this is an exciting time. Like we are going to fundamentally change an industry that hasn't changed much. And, you know, I think for me is the ability to have the pace to do it fast enough, but not too fast. So we get it right in terms of timing, and that we can do it in a way that gets our customers to come along in the journey that ultimately benefits all customers, not just a few. So, you know, as a company, it's an exciting journey, and I'm thrilled to be part of it. But, you know, it's a big change, and you know, we all need to work together to make it happen.
Yep, absolutely. Gentlemen, final thoughts, Llewellyn, or you're muted, Llewellyn.
It's a very interesting, Carlos, and I'm watching with extreme interest how we're going to make this transformation. It seems to me that in my time of covering the electric utilities, the first big event was nuclear power in the 60s and 70s. Then we had the energy crisis, and a huge dependence on coal was built up. And then came the 90s, and you know, an amazing number of things came together: fracking, aeroderivative turbines, and the gas surplus, which resulted in the almost instant switch to gas, and gas being chosen clearly over nuclear and over coal. And now we're ready for some other major transformation, which I think will be driven by AI, but that's not the whole story. We're going to need gas, and we're going to need the renewables, because demand is increasing, especially in a state like Texas. So it's a challenging time and an interesting one.
Yeah.
Yes, it's very challenging, but your advantage is, unless Nikola Tesla wakes up, is that you don't have much competition. Unless Nikola wakes up and said, "The hell with the grid, we're going to run everything through the ground," and so therefore you're out of business. So I think what's very important is that the new technologies that will guide us to the future it is a regulated industry, much like the airline industry is regulated, and it has to do great things. It's been the best machine in the world for the last 100+ years. So continue to do great things and keep the lights on. And thank you for doing what you do.
Yeah, well, thanks for the invitation, guys.
Absolutely. Johnny, take us away. Where's the guitar?
There ain't no use sitting wondering why, babe. It don't matter anyhow. And it ain't no use to sit and wonder why, babe. If you don't know by now, when the rooster crows at the break of dawn, look out your window and I'll be gone. You're the reason I'm traveling on. Don't think twice, 'cause it's all right.
Woo! Thank you, Johnny.
No
Thank you,
problem.
everybody. I'm going to stop.